They come from distances we cannot imagine. Objects that do not belong to our solar system. Objects that travel for millions of years through the dark between stars. Most of them pass without being seen. Most of them leave no trace, no memory, no record. But some do not simply move through space. They intrude. The ones that do not just appear, they announce themselves. A strange visitor from interstellar space, catalogued as 3I Atlas, reached its closest point to the Sun. This was not the first interstellar object we had seen, but there was something different about this one. Something older, something colder, something that did not behave the way a comet should, something more ancient, more unpredictable, more alive. We had first detected it weeks earlier, moving fast, cutting across the night sky at a trajectory that made no orbital sense. Objects born in our solar system follow closed paths, ellipses, loops that always return. But interstellar objects do not return. They enter, they pass through, and they leave forever. 3I Atlas was one of these, a visitor, a messenger, a piece of somewhere else. Its speed alone told us that it came from beyond our star's gravity. Its chemical fingerprint suggested that its ice had formed in an environment far colder and older than anything in our system. It was, quite literally, a fragment of another world. But the deeper we studied it, the more wrong it looked. The brightness curve rose too quickly, as if the sunlight touching it was igniting something beneath its surface. Its coma, the cloud surrounding it, expanded unevenly, like something was breathing inside it. And the spectral lines, they hinted at molecules we did not expect. Molecules that suggested chemistry and temperatures far below the lowest cosmic background expected at its origin. The numbers didn't match. And when numbers do not match in astronomy, the universe is telling us that our understanding is incomplete. Scientists tried to stay cautious. They compared it to the first interstellar visitor, Oumuamua, which had passed in 2017, an object that accelerated away from the Sun without any visible gas emissions. Something had pushed it, and we still do not know what. They compared it to 2I Borisov, the second interstellar visitor, which had behaved more like a normal comet. But 3I Atlas did not behave like either of them. It sat awkwardly between them, familiar and yet alien. As it approached the inner solar system, astronomers tracked it closely. Space telescopes, ground observatories, radio interferometers, all pointed toward this intruder. Data poured in, models were updated, predictions adjusted. But the closer it came, the less sense it made. It was shifting, not just in brightness, but in color. The light bouncing from it began moving toward the blue, toward shorter wavelengths, toward higher energies. Comets do not do that. Ice does not do that. Light does not do that, unless something is happening that is not purely reflection. And then it reached perihelion, the closest point to the Sun, and from our view, it moved behind the Sun. The Sun's glare blinded everything pointed at it. Even our space-based telescopes were overpowered. For 8 days, we saw nothing. No data, no images, no telemetry, no trace. It was as if the object had been swallowed by the Sun. Astronomers waited, and waited, and waited. Those 8 days felt longer than any 8 days in recent scientific history, because everyone understood the stakes. If the object re-emerged unchanged, then perhaps it was nothing more than a strange comet, a curiosity, a footnote. But if it re-emerged different, then something profound, something foundational, something impossible might have occurred. On the morning of the 8th day, telescopes detected a faint streak of blue-white light emerging from the far side of the sun. At first, no one believed it. Instruments were recalibrated, data was checked, models were rerun, because what we saw was not what we lost. 3i Atlas had returned, but not as it was. It was brighter, much brighter, too bright. It was emitting more light than a comet of its size and composition should. It was as if the sun had not just heated it, but changed it, transformed it, awakened something inside it. The coma now formed sharp, layered structures, filaments, ridges of ionized gases twisted into patterns no gravity-driven outflow should create, and the spectral signature, the chemical identity of the light, had changed. It now contained ionized carbon chains and high-energy radicals that could not have formed simply by heat exposure. Something else had happened, something we did not see, something we still do not understand. What happened behind the sun? We have theories, but none are comfortable. We called them the 8 days of blindness, not because the sun hid the comet, but because it exposed our limits. Our sensors were deafened, our mirrors saturated, our algorithms reduced to wishful extrapolations. We had numbers where we wanted sight, and predictions where we needed proof. And in that narrow gulf between what was measured and what was real, 3i Atlas crossed behind the star that made us and rewrote something we did not know could be rewritten. In control rooms across the world, clocks ticked louder than voices. Time was an instrument too, carved into windows for tracking, and every hour without a signal built pressure inside the people who had to admit, silently, that the universe does not schedule its revelations, it ambushes them. We modeled sublimation fronts peeling off ancient ice. We modeled jets on the sunward side and fractures cascading through a nucleus that had never felt this much heat. We modeled dust storms of charged grains coupling to the solar wind, the tail buckling, the coma breathing, the nucleus precessing like a lopsided gyroscope. But each model demanded assumptions that felt like apologies, and the more elegant the equation, the less it tasted like truth. Then came the rumors, the quiet kind, the ones that ride on late-night messages between colleagues who trust each other enough to doubt out loud. What if the spike in brightness before ingress was not thermal at all? What if the color shift meant excitation, not reflection? What if we were looking at chemistry driven by fields we had not mapped on that side of the sun? The idea sounded reckless until it did not. The heliospheric current sheet, the wrinkled magnetic boundary that drapes the solar system like a wavy skirt, folds close to the sun. What if the visitor sliced through a shear in that sheet at just the wrong or right moment? What if charge exchange lit the coma from within? What if plasma, not sunlight, wrote those colors? Day 5 arrived with nothing but thermal noise and persistence. Someone in Hawaii recalibrated flats for the 3rd time. Someone in Chile rechecked pointing offsets against guide stars they could not see. Someone in Madrid swore softly in a room that smelled like coffee, cooling too fast. Hundreds of someones, everywhere, moved sliders, tightened tolerances, chased ghosts through pipelines, because this is how science sounds when it is honest. Patient, repetitive, humbling. By day 7, we had a plan for what to do if it came back brighter, and a plan for what to do if it came back fractured, and a plan for what to do if it did not come back at all. Contingency scripts sat open like unplayed scores, each a different kind of music, each asking for a different tempo. But the plan no one wrote, the one we should have, was what to do if it came back changed in a way that did not fit any instrument we owned. Dawn on the 8th day blurred into a rumor on a private channel. A thin thread at the edge of saturation, a line a little too blue in a place a little too empty. The first response was, "Check the bias." The second was, "Check again." The third, whispered, was, "If this holds." It held. The detection firmed into a path, the path into a reappearance, and the reappearance into a fact that felt like a question. Three-Eye Atlas was back, but its light wore a new grammar. Brightness without mass loss we could quantify. A spectral tilt toward shorter wavelengths, ion lines flaring where we expected only dust signatures. The coma's outer shell shaped itself into ribs and blades, as if something invisible pressed and released in rhythms we could not time. Instruments that had never agreed on one thing. The geometry of the tail was wrong. Gravity writes curves. This was calligraphy in angles, sharp, sudden, almost architectural. We mapped the kinks against the solar wind, and the wind did not take the blame. We mapped the folds against the sun's magnetic domains, and found hints, not answers. We mapped our own certainty, and discovered how small it was. In the meeting that followed, someone brave said the quiet part. Maybe the sun did not just heat the visitor. Maybe it introduced it to a landscape of forces that we only name in textbooks. Reconnection, double layers, alphenic turbulence braided tight enough to pluck a coma like a string. The room did not laugh. The room took notes. The simplest story, ice swarms, gas flows, dust shines, had failed a test we did not design. The new story would cost humility, and that price is always due up front. We broadened our priors. We allowed for exotics in the nucleus, hypervolatiles buried under crusts older than our continents. We allowed for electrostatic cohesion and brittle failure that vents in pulses instead of sighs. We allowed for the possibility that the object carried a memory of fields from its birth cloud, a fossil magnetism now being played by a different star. Someone asked if anything broke. The answer depended on what you meant by break. The object was intact by brightness, and yet the map inside our heads, the one that equates comet with snowball and snowball with simple, had a crack running through it. If you listened closely, you could hear it widening. That night, when the world turned and the telescopes that had been in daylight woke up under new skies, the data rate surged. Spectra stacked like city skylines, each line a lighted window telling a partial story. Photometry beat like a pulse. Polarimetry whispered about grain shapes and fields. And still the most honest sentence we could print was the oldest one we know. Something happened behind the sun. We do not yet know what that something is, but we know what it is not. It is not merely heat, it is not merely dust, it is not merely chance, and if it is a conversation between a star and a wanderer, then we have arrived in the middle of it, without context, hearing only every third word. The wise thing, then, is to stop speaking and start listening. Tomorrow, we will turn our questions into targeted observations. Tomorrow, we will slow the heartbeat of speculation and let the new light teach us its rules. But tonight, the 8 days of blindness end with a truth that feels like a horizon. When we could not see, something saw us. The limits of our instruments, the shape of our assumptions, the way we look away when the sun is too bright. Tomorrow, we look again. When 3-Eye Atlas returned from behind the sun, the first thing we noticed was its brightness, and not in the ordinary way comets brighten. Normally, as a comet approaches a star, heat causes volatile ice to sublimate, forming a coma that reflects sunlight. That reflection is passive, predictable, and mathematically smooth. But what we saw was not reflection. It was emission. The light coming from the object was being produced by the object as if something within it had been activated or energized. Spectral lines confirmed this immediately. High-energy ionization states appeared that could not be accounted for by solar heating alone. The intensity and wavelength shift suggested not just elevated temperature, but an internal energy source, or the influence of forces acting directly on the molecular bonds within the coma. This was the first impossibility. The second was the shape. A comet's coma is traditionally diffuse, a soft cloud of dust and gas. But the coma surrounding 3-Eye Atlas after its reemergence was structured. It contained repeating filaments, thin, luminous strands spaced at consistent intervals, as if guided or constrained by an invisible lattice. Natural turbulence does not generate repetition. Chaotic systems do not produce symmetry unless a stabilizing force is present. We had no known stabilizing force here. The sun's magnetic field interacts with charged particles, yes, but not in a way that produces geometry. Yet the structure was unmistakable. It was deliberate in appearance, though we could not claim intention, only pattern. The tail presented a third anomaly. Instead of flowing smoothly outward, shaped by solar wind pressure, it formed angular planes and sharply defined edges. It looked carved, sculpted, as though invisible hands had taken hold of the streaming material and drawn lines through it. Gravity cannot do that. Plasma pressure cannot do that. Outgassing jets can momentarily disrupt tail formation, but they do not create extended shapes that hold. The tail geometry was impossible under any known physical scenario. And yet, there it was, traced clearly in the data, photographed from observatories on 3 continents. Then we examined the rotation. Before disappearing behind the sun, 3-Eye Atlas had rotated at a steady, measurable rate. After re-emergence, its rotation axis had shifted. The nucleus had effectively rebalanced. This implied internal mass redistribution. Comets do not do that. Their structures are weak, porous, fragile. Internal rearrangement on that scale would require either catastrophic fracturing, which we did not observe, or processes we do not understand. The nucleus was intact, but it was changed, as though something had moved within it or through it. And then there was the color. It was no longer simply blue. It was electric blue, the kind associated with ion storms, magnetically confined plasma, laboratory fusion arcs. This coloration indicates interactions between matter and structured electromagnetic fields. But the sun's magnetic field in that region was mapped, studied, predictable. There was nothing in available solar data to explain the intensity or pattern of the ionization. This left only two conclusions. Either our maps were wrong, or the object had encountered a field configuration we had never observed before. One of the researchers at the ESA Deep Space Observation Team described the sight of the re-emerged comet with a phrase so simple it silenced the room. "It looks like something wrote on it." Not literally carved symbols, but altered its physical state in a way that felt intentional, or at least directional. As though the change was not random. As though the sun had not just heated the comet, but interacted with it. The word everyone was thinking, but no one wanted to say, was contact. Contact not with intelligence necessarily, but with a form of solar or cosmic behavior we have never recorded. A force, a field, a resonance, a layer of physical reality we had not included in any model. Something happened behind the sun that does not belong to ordinary astrophysics. The comet did not simply survive perihelion, it emerged revised. Science is not afraid of the unknown. Science is built to walk into darkness with light held forward. But science does fear what cannot be classified, because what cannot be classified cannot be predicted, and what cannot be predicted cannot be controlled, and what cannot be controlled cannot be integrated into our understanding of the universe. When 3I Atlas returned, it did not just challenge our observations, it challenged our assumptions, and assumptions are the skeleton of knowledge. The data was real, the images were real, the spectra were real. Nothing about this was imagination, exaggeration, or myth, and yet the meaning pressed against us from behind the eyes, like a truth waiting to be acknowledged. The universe had spoken, and the message was unmistakable. You do not know everything. You are not finished. Look again. The moment 3I Atlas reappeared and the first meaningful data sets were confirmed, the scientific community split, not in disagreement, but in direction. Everyone accepted that something happened. The question was what, and the answers fell into distinct schools of thought, each trying to decode the same signal. The first theory was the thermal reconfiguration model. In this interpretation, the sun's heat triggered extreme internal sublimation, rearranging the nucleus from the inside out. Pockets of volatile ices, buried for billions of years, could have vaporized rapidly, shifting mass, altering rotation, and venting material in patterns that appeared structured. But the problem with this model was one of consistency. Internal sublimation should have produced fragmentation, visible cracks, asymmetrical outgassing, chaos, not symmetry, not repeating structures, not a smooth, rebalanced rotation. The object should have looked damaged. Instead, it looked transformed. The second major hypothesis came from plasma physicists, who recognized something familiar in the comet's new electric blue spectral lines. According to the magnetohydrodynamic resonance theory, 3I Atlas encountered an intense plasma environment near the sun, perhaps within a highly wrinkled fold of the heliospheric current sheet. In this model, the coma did not glow because it was hot, but because it was being energized by the sun's magnetic fields. Charged particles trapped in the comet's coma could have undergone resonant excitation, creating self-sustaining emission, a kind of natural plasma lamp in space. This theory explained the color and light emission, but it did not explain the geometry of the coma, nor the sharp-edged tail. Magnetic fields can create filaments, yes, but they do not arrange dust into repeating spatial intervals unless something is controlling the interaction very precisely. And nothing about the Sun's near-surface magnetic environment is precise. It is turbulence incarnate. To get order from chaos, something had to be guiding the pattern. This is where the third hypothesis emerged, controversial, uncomfortable, and whispered before it was spoken aloud. The field memory hypothesis suggested that 3I Atlas did not simply react to the Sun, it recognized it. That is, the object carried a residual electromagnetic or structural signature from the star system where it originally formed, and when exposed to the Sun's magnetic gradients, it resonated, not randomly, but in accordance with a pattern encoded at its birth. In this view, the comet was not changed, it was revealed. This would mean that the object was older than our Sun, older than many stars in our region of the galaxy, possibly formed in a colder and more chemically exotic environment. This would explain the unusual molecules, the electric emissions, the rotation change, even the structured coma, not as new features, but as features that had been dormant for millions or billions of years. The Sun simply turned them on. But this theory implied something larger, that interstellar visitors carry imprints of their origins, and the galaxy is not homogeneous, but a tapestry of different physical regimes, each writing its own signature into matter. This was not just a scientific hypothesis, it was a philosophical one. It challenged the idea that the universe is consistent, uniform, predictable. It said, "Where you are born changes what you are." Yet, there was a fourth theory, one that scientists approached with the same caution used when handling radiation, carefully, slowly, with controlled language. The interaction hypothesis. Unlike the others, it did not claim to know how the comet changed. It simply claimed that something acted upon it, a force, a field, a phenomenon not yet categorized, not supernatural, not intelligent in intention, but non-local, not determined solely by proximity to heat or gravity or magnetism. Something emergent, something relational, something that required the comet and the Sun to be together for the effect to occur. In this model, the event behind the Sun was not a mechanical process, but a conversation, matter responding to environment in a way we are not used to observing. The same way sound waves behave differently in thick air and thin air, the same way quantum states shift based on the presence of observers, the same way water changes shape based on temperature and pressure. Except here, the environment is a star, and the thing responding to it came from another star entirely. The reason this hypothesis scared people was simple. It required humility. It required us to admit that our models of stellar environments are incomplete, that what we call known physics may be a subset of a larger framework we have only begun to glimpse. To accept this theory is to accept that the universe is not just larger than we understand. It is structured in ways we have not learned to think in yet. No single theory answered everything. Each explained part of the data, but not all of it. And the object itself, silent, drifting onward, leaving the inner solar system with no intention of returning, offered no clarifications. The comet was not trying to be understood. It did not remain in view long enough to settle the argument. It came, it changed, it left. In its passing, it left us with something rare in modern science, not confusion, not fear, but curiosity sharpened into urgency. A reminder that the universe does not exist to be simple, and that the moment we believe we have understood everything, something will appear to prove us wrong. What happened next was not loud, and it was not dramatic. It unfolded in conference calls, in silent lab corridors, in message threads that grew longer and slower as people typed more carefully than they spoke. Scientists are trained to argue, but this was not argument. It was something softer, something more fragile. A collective realization that the object we had observed defied the categories we rely on to make the universe understandable. There were those who insisted that nothing truly new had occurred, that 3I Atlas was simply a comet undergoing extreme thermal stress, and that everything could be explained through the stubborn, grinding patience of conventional physics. Others countered that the spectral lines, the angular tail geometry, the rotational shift, the structured coma, all taken together, pointed to an interaction we did not have a name for. And then there were those who simply sat in the pauses and listened, knowing that none of us really wanted to say the words we were circling, that this object had changed our understanding not through what it was, but through what it forced us to confront about ourselves. Meetings turned into quiet rooms where people stared at models that refused to balance, equations that led into empty space, graphs that implied energies with no source. A graduate student in Tokyo found a correlation between the filament spacing in the coma and the frequency of solar magnetic oscillations, but the result was dismissed as coincidental pattern emergence, because accepting it would mean rewriting the boundary conditions of plasma dynamics near stellar bodies. A postdoc in Arizona proposed that the rotation shift was the result of external torque from asymmetric plasma coupling. The idea was promising until someone simulated the necessary field conditions and realized they should have torn the comet apart, not rebalanced it. Theories bloomed and withered in the space of days, sometimes hours. Datasets were reprocessed, recalibrated, cross-verified. No one wanted to get this wrong, because no one could afford to. The question that emerged, slowly, reluctantly, was not, what happened to 3I Atlas, but, what does it mean that we cannot say? That was the fracture line, because astronomy has always relied on distance to protect us. The stars are far, the galaxies are far, the mysteries are far. But this was not far. This was here, in our system, under our star, within the reach of our instruments, our equations, our language. And still, it slipped through our fingers. Somewhere in the discussion, a shift occurred, subtle but irreversible. The object itself was no longer the center. We were. The limits of our perception, the architecture of our assumptions, the scaffolding we use to build meaning from the sky. 3I Atlas became a mirror, not a message, not a warning, just a reflection of how much of the universe we have not yet learned to see. And because no one wanted to say it, the silence said it for us. We are not just observers of the universe, we are students of it. And this was a lesson. What unsettled people most was not that 3I Atlas changed, but that we did. The comet continued on its trajectory, indifferent, silent, disappearing back into the dark between worlds. But the conversations it left behind did not fade. Something had been revealed, though no one could say exactly what, and that ambiguity spread through the scientific community like a quiet undertow. It made researchers look longer at graphs they would have closed, re-examine assumptions they would have accepted, question theories they once defended with certainty. The event did not wound our understanding, it humbled it. And humility, when it enters science, is not weakness. It is the beginning of expansion. In lecture halls, professors found themselves hesitating at lines of explanation they used to deliver without thinking. In offices late at night, graduate students hovered their cursor over equations that once felt solid but now seemed merely convenient. In observatories, people looked at the sun differently, not as the familiar anchor of our system, but as something stranger, deeper, capable of interactions we had never been taught to imagine. And beneath all of this was a realization so quiet, it felt like something remembered rather than learned. The universe does not exist for our understanding. It does not shape itself to fit our diagrams or bow to our vocabulary. We are the ones who reshape. We are the ones who adjust. And sometimes the universe presses back, not to confuse us, but to remind us. There is a belief, rarely spoken aloud but often felt, that science progresses through answers. But in truth, science progresses through questions that refuse to go away. And 3I Atlas was not an answer. It was a question with mass and motion. A question we could point a telescope at. A question that left visible trails across CCD sensors and spectral arrays. And yet, even with all that, the essential truth remained just out of reach. This is why the comet mattered. Not because it changed physics, but because it exposed where physics still has space to grow. It reminded us that certainty is not a destination. It is a temporary resting point on the way to deeper uncertainty. And that is not failure. That is the nature of discovery. Some scientists responded with excitement, the kind that keeps a person awake through the night without coffee, the kind that makes a new research field feel like a frontier. Others responded with discomfort, because recognizing the horizon is moving means accepting that we stand on ground that is not fixed. And for humans, whose minds crave structure and confidence, this is a difficult truth. But difficult truths are where humanity has always made its greatest leaps. The realization that Earth was not the center. The realization that time is not absolute. The realization that space can expand. Every one of these discoveries required someone to look at data that did not fit and say, maybe the world is larger than we thought. 3I Atlas asked us to say it again. The event also reopened an old question, not scientific, but human. What do we hope to learn from the universe? Are we asking because we want control? Or because we want understanding? Or because something in us recognizes the vastness outside and refuses to be small? The comet did not answer this. It simply made the question unavoidable. And in that way, it became a mirror held up to the species that looked at it. We saw, reflected back at us, our curiosity, our fear of the unknown, our hunger for meaning, our impatience with mystery, and our inability to admit how much of the cosmos remains untouched by our comprehension. But there was something else reflected too. Something quieter and more important. Wonder. Not the childish kind that fades, but the deep, grounding kind that reminds us why we began looking at the sky in the first place. Before equations, before telescopes, before missions, there was the simple act of lifting our eyes upward and knowing that what we were seeing was bigger than us. 3-Eye Atlas brought that back, not through spectacle, not through disaster, not through revelation, but through mystery that endured. And maybe that is the most meaningful thing it left behind. Not a discovery, not a breakthrough, not a theory, but a reawakening. We were reminded that the universe is not done surprising us. And we are not done learning how to see it. The more we studied 3-Eye Atlas, the more its silence widened around us, not as an absence of information, but as an invitation to look further than we are used to looking. Space has always appeared limitless in a way that feels abstract, a kind of poetic infinity. But the passage of an interstellar object makes that infinity real. It is proof that the galaxy is not a distant backdrop, but a continuous landscape, where matter drifts from one star's gravity to another's, carrying with it histories older than our world. 3-Eye Atlas did not belong to us. It did not know our sun, our planets, our languages, our instruments. It came from somewhere we have not mapped, from conditions we have not replicated, from a time we cannot place on our timeline. And as it moved away again, accelerating along a hyperbolic escape path that guaranteed it would never return, the scale of that distance began to settle into us. The universe was not just big, it was layered, textured, structured across spans of time and space so large that human comprehension bends when trying to hold them. And yet, the object had crossed all of that. It did not ask permission. It did not slow to introduce itself. It simply moved through. And in doing so, it forced us to see that our solar system is not the center of anything. It is a clearing in a vast forest we barely know how to walk through. The event behind the sun reminded us that the processes shaping the universe are not concerned with our readiness to understand them. They unfold whether we are watching or not. Our models are temporary. Our explanations are scaffolding. The truth is deeper than the tools we have built to reach it. That realization did not diminish us. It clarified us. It showed us that knowledge is not a possession. It is a direction. And we are still, and perhaps always will be, at the beginning of it. In the months that followed, the sky went on being itself, indifferent to our urgency, and 3-Eye Atlas dwindled into a line of numbers and a fading streak that only the most patient exposures could still recover. But its absence carried weight. Proposals were written to redesign instruments for the next time an interstellar object skirts the sun. Missions were sketched that could pivot fast and fly close. Coronagraphs were reimagined to hold steady against glare while a wanderer slips through the furnace, and software teams quietly rebuilt pipelines to keep us from being blind when the universe chooses to speak behind our star. None of this made headlines, and that is fine, because the real consequence of the event was never spectacle. It was a shift in posture, shoulders lowered, eyes steadier, language cleaner, the kind of humility that makes a field stronger. We learned to treat the unknown not as a gap to be filled with confident words, but as a terrain to be mapped with patient questions, to accept that the neatness of a theory is not proof, that symmetry can be a trap if it is only in the math and not in the sky, that a model is a promise we make to remain corrigible. Teams that had seldom spoken to one another began meeting on odd hours across time zones. Heliophysicists with comet dynamicists, plasma theorists with observational astronomers, instrument builders with data ethicists. Because what happened behind the sun did not recognize our departmental borders, and so we learned to let them blur. A few people left the conversation, deciding the mystery was an unnecessary complication, but most stayed. And among those who stayed there grew a calm resolve that the next visitor, whether it is catalogued 4I or marked by some other letter we do not expect, will find us more ready than before, not in the sense of having an answer, but in the better sense of having the right questions sharpened and laid out like tools. Even the public, those who only caught fragments of the story, seemed to understand that something unusual had passed by us, because the letters to observatories and museums carried a different tone than usual. Less about aliens, more about awe, more about the strange fact that we live under a star that can still surprise the species that grew up under it. In classrooms, students asked better questions. What is a field, really? What does interaction mean when it is not between bodies, but between behaviors? How do you design an experiment for an event that cannot be scheduled? And teachers had the unexpected pleasure of saying, "We do not know yet," without embarrassment. In that way, the comet altered more than data streams. It altered permission. Permission to wonder without apology. Permission to pause before naming. Permission to leave certain boxes unchecked until the evidence earns the ink. And quietly, almost invisibly, the discipline adjusted its aim. From defending what is already known toward illuminating what might be true. But all of that is the surface of a deeper shift, the one that matters, the one no grant can measure. We remembered that the cosmos is not a problem to be solved. It is a relationship to be tended. That our instruments are not just machines for extracting answers, they are ways of listening. That to stand on a small world around an ordinary star and feel bewildered is not a flaw of cognition, but a sign that cognition is working. So let the record show, for whoever reads the logs when our names are gone, that a traveler from elsewhere slipped behind our sun, and when it emerged, something in us had moved as well. We will argue about which theory was closest. We will refine the spectra. We will publish the curves and the codes. We will forget some of the late nights and most of the small frustrations. But what will remain, what must remain, is the posture we found in the long afterglow. Attentive, patient, self-correcting, brave enough to say, again, when the sky offers another riddle. Because the universe did not change its laws on our account, it only showed us where our comprehension had not yet reached, and that alone is enough to guide a life's work. We are not the center of this story, but we are permitted to read it, line by line, visitor by visitor, question by question. And if there is any conclusion worthy of the silence that followed, 3I Atlas. It is the simplest one we learn to say without flinching. We do not know everything, we are not finished, and we will